Welcome to ZTech Advisor YouTube channel and to our comprehensive guide on the OSI model, your roadmap to understanding how data travels across networks. In this video, we break down the OSI, Open Systems Interconnection, model into 7 digestible layers, demystifying the complexities of networking protocols and communication processes. Physical layer. Function. Transmits and receives raw data bits over a physical medium, cables, wireless signals. Analogy. The wires and cables that carry electrical signals. Real-life example. The network cable connecting your computer to a router transmits electrical signals representing the data you are sending or receiving. Analogy. Imagine it as the road network, the actual pathways for cars, data. It includes cables, fiber optics, and wireless signals. Protocol. Ethernet. Defines the physical and electrical characteristics of the network medium, such as cables and connectors. DSL, Digital Subscriber Line, provides high-speed internet access over telephone lines. Protocols, Ethernet, Wi-Fi, Bluetooth, USB, and others. 1. Data link. Prepares data for transmission, adds MAC addresses, and detects/corrects errors. Analogy. Think of it as the assembly line in a car factory. It organizes frames, like car parts, and ensures smooth flow. Real-life example. When you connect your computer to a network switch, your network card, Layer 2, adds a unique MAC address to each data frame it transmits. The switch uses these MAC addresses to forward the frames to the correct destination device on the network. Protocols. Ethernet. Ethernet is a widely used protocol for local area networks, LANs. It defines the rules for how devices communicate on the same network segment. IEEE 802.11 Wi-Fi. This protocol governs wireless local area networking, WLAN, standards. It allows devices to communicate wirelessly within a local network. PPP, point-to-point protocol. PPP is a data link protocol used to establish a direct connection between two nodes. It's commonly used for dial-up internet connections and WAN connections. HDLC, High-Level Data Link Control. HDLC is a bit-oriented synchronous data link layer protocol. It's often used in synchronous serial communication, such as connections between routers. Network layer. Function. Routes data packets across networks based on logical addresses, IP addresses. Analogy. Visualize it as a GPS system guiding your car. It determines the best route, path, for data packets to reach their destination. Real-life example. Your computer sends an email to a friend. The network layer, Layer 3, examines the destination email address and uses routing protocols to determine the path the email packets should take to reach the recipient server. Network layer protocol. Internet protocol, IP is the foundational protocol of the Internet and is responsible for addressing and routing packets across networks. It provides the basic framework for delivering data packets from a source to a destination across networks. ICMP, Internet Control Message Protocol. ICMP is used for diagnostic and error messaging within IP networks. It includes utilities like ping, traceroute, and ICMP error messages. ICMP is vital for network troubleshooting and management. ARP, Address Resolution Protocol. ARP is used to map IP addresses to MAC addresses on a local network. It's essential for communication between devices within the same subnet, enabling devices to locate each other on the local network. Transport layer. Transport layer, Layer 4. Function. Breaks data into smaller segments, and ensures reliable delivery. Analogy. Consider it like a postal service. It divides your letter into smaller envelopes, tracks them, and ensures they reach the recipient. Real-life example. TCP, reliable, and UDP, unreliable, protocols operate at this layer. Transport protocols. Transmission Control Protocol, TCP, which ensures reliable, ordered, and error-check delivery of data. User Datagram Protocol, UDP, offering lightweight, connectionless communication suitable for real-time applications. And Stream Control Transmission Protocol, SCTP, combining features of TCP and UDP for robust, message-oriented communication with support for multi-homing and congestion control. Session layer. Function. Initiates, maintains, and terminates communication sessions. Analogy. Think of it as a virtual handshake, a session manager ensuring smooth interactions. It sets up, manages, and closes connections. Real-life example. Logging into a remote server or starting a video call involves the session layer 1. Session layer protocols. Layer 5 of the OSI model primarily handles session management between applications. Protocols at this layer establish, maintain, and terminate communication sessions between devices. Common examples include NetBIOS, Network Basic Input-Output System, which facilitates session services for communication between computers on a local network, and protocols used for establishing and managing VPN connections like PPTP, point-to-point tunneling protocol. Presentation layer, function, handles data formatting, encryption, and compression. Analogy, imagine this layer as a language translator. It converts data into a common format for seamless communication between devices. Real-life example. When you download an image from the internet, it's compressed, JPEG format, and decrypted, if encrypted, by this layer. Presentation layer protocols. The presentation layer, layer 6, of the OSI model focuses on data formatting, encryption, and compression for efficient and secure transmission. While it doesn't have standalone protocols, technologies such as SSL/TLS are closely associated with its functions, providing encryption and decryption for secure communication. Additionally, ASCII serves as a standard for character encoding, ensuring consistent representation of text data. Multimedia standards like JPEG and MPEG handle compression and encoding of images and videos, aligning with the presentation layer's responsibility for data representation. Application layer. Application layer, layer 7. Function, provides an interface for applications to communicate over the network. Analogy, picture it as a smartphone app store, where various apps, like browsers, email clients, and video conferencing tools, reside. You choose and interact with these apps to perform specific tasks. 1. Real-life example. When you open your web browser to visit a website, you're using the application. Protocols. The application layer, layer 7, of the OSI model facilitates communication between end-user applications and the network. It includes a variety of protocols and services that enable users to access network resources and services. Examples include HTTP for web browsing, SMTP for email transmission, FTP for file transfer, and DNS for domain name resolution. Each protocol within the application layer serves specific functions, allowing users to interact with network services seamlessly.